Hey everyone, welcome to the ECS workshop. We're going to get started in just a few minutes, but we just wanted to say a quick hello. And yeah, just feel free to take a look around. You'll see at the bottom of the workshop here, there's an introduction video that just guides you on how to use the platform. Highly recommend you just do a quick watch on that. So as we go through the workshop, you'll know all the cool features that we have available. So sit tight, and we'll be back here in just a couple of minutes to get started. Okay. Well, hello everybody, and welcome to the introduction to Amazon ECS workshop. This is a near and dear to Brent and our hearts. We love this workshop, and we're really excited to walk everyone through it today. Before we get started, I think what we should do is probably a quick overview of what we're going to talk about today. Brent and I will introduce ourselves, and then maybe we'll walk through the platform and kind of what you can expect and what to look for. So let's actually start with just quick introductions. So my name is Adam Keller. I'm a developer advocate on the container services team here at AWS. So if you ever see me, you'll see me talking everything containers. I love ECS, a big fan of it, and we've done so much with ECS, and we're doing so much more in the future. So I really love talking about it. You can see here, this is my Twitter handle here. So if you want to reach out to me and say hello or follow along as I talk all things containers, please do. So Brent, go ahead. I was talking way too much there.
Oh, come on. I was actually wondering if I'd be able to go this whole workshop without talking. So I'm Brent, and if anyone knows me, you know that's impossible. So I'm Brent Langston, also a developer advocate. So I've been at AWS now for about 4 years, and I created ECS Workshop several years ago, but it's evolved. Adam has taken over ownership of it and really kind of made it great. And so we really enjoy putting this on and hosting it. So there's a couple of things that we want to walk you through just to make sure that everyone is starting off on the right foot. First, we are giving you a credit code. So bring your own AWS account. And if you apply this credit code in your account, then you'll get credit that will let you work this workshop for the next, I don't know, day or two at least. We didn't really measure it out to know for sure how much or how long you can go. But at the same time, do make sure that at the end of the workshop, there's a cleanup section. Go through that and make sure to clean up any resources, because we don't want you to keep getting charged past your credit. So you'll have a few days worth of compute, so you can definitely take advantage of that. The other thing we wanted to point out is you have the ability to share feedback with me, and I'm monitoring for feedback. It'll come in anonymously. Adam, let's demonstrate. So go ahead and type something in the box and then hit submit.
And you can choose thumbs down, thumbs up, or if it's a question.
Nice.
Select question and then hit submit.
And so I just see it from by some random hash. Hello, you guys are the best. So definitely, if you want me to tell Adam, blow the font up or something like that, then I'll definitely, sort of, what's the word? I'll relay any feedback to Adam without having to interrupt him or distract him with having to follow chat. We also have helpers that can help answer deeper questions. So when there needs to be, I have no way to respond to you. So that feedback is one-way communication and it goes to me. We also have helpers standing by that if you need two-way communication, you want some help figuring out you're seeing an error that we didn't get on our screen, there's a typo or anything like that. Let's demonstrate joining the workshop chat room, Adam.
Okay. Well,
there's a little button below where you type in the feedback that you can accept the code of conduct. You're going to be good humans.
Yes.
And you can join the chat, and this will drop you into Discord. We won't make Adam actually launch the app or anything like that, but this will drop you into Discord where people are standing by ready to chat with you and respond. And if typing isn't your thing, there's also the possibility of doing voice using Discord. So you can speak to someone instead of type chat to them. So it's your choice. And then before you leave, we're going to remind you of this once or twice throughout the workshop, but there's also take the exit survey. And we want to make sure that we listen to your feedback. So definitely don't forget to take that survey. If you're only hearing us and you're wondering where these voices are coming from, there's an orange button there to pop open the video. And if you do that, then you see our video, and you can pop that out into its own tab and put it off to the side if you want, and then you can follow along sort of in separate windows. So wow, that's a lot of mirror effect.
Sorry, I popped it out. I got rid of it.
Nice. So I see a question in Discord, and I'm I'm going to try and answer if there's something that might be appropriate for everyone. I'll try and answer it on the stream. Also, the question is this being recorded? Question mark, or ECS workshop? Question mark. It's a couple of questions there. One, is it being recorded? Sort of. No, not formally. We have recorded these in the past, though, and you can find one or maybe two of some fairly recent ones that we have recorded before on our YouTube channel that you can get to at containersfromthecouch.com. So if you're not familiar with me and Adam, we run a show that's containersfromthecouch.com, and we talk about all things containers. We have guests on. It's very demonstration heavy. We will run through parts of workshops sometimes, especially when we've added a new section. So on that YouTube channel, this link will take you to our YouTube channel. On that YouTube channel, you'll find a recent running of this workshop. Second question was, where can I find this workshop? I think is where I find yeah, and you can find it at ecsworkshop.com. So definitely, like, for today, follow along in Eventbox. That way you have access to our live stream, and you can see, you know, what's going on and how things are going. You can do all the feedback stuff. Someone said, I can hear you again, in their feedback to me. Good. I didn't know you couldn't. So
that's great news.
Good that you can again. So yes, follow along with eventbox.dev today. But if you wanted to pass this along to a coworker, you wanted to come back to it next week or something like that on your own time, you can definitely do it on your own at ecsworkshop.com. And we're going to always be updating that and keeping it up to date. It's been around for years and will be around for years to come. So it's a great place to go for anything ECS related. So,
yes. Should we get started?
I feel like we should, and we should now kind of dive into the workshop structure a little bit and talk about what are we going to talk about today.
Yes. So thank you, Brent. So a couple of things here. One, going back to what Brent was saying about the workshop. So one thing you'll notice is Brent and I, we may run through certain topics a little faster than you may like. But the idea is we want to make sure we get through. We want to make sure we get through all the content. So if there's something that you feel stuck on, ask questions. And if somehow it's past the workshop, ecsworkshop.com is there. You can go back and really just dig into these concepts to familiarize yourself. Also, what we're going to do today is we're actually going to deploy a 3-tier microservices application. Microservice application. Yes. And
a 3-tier application of microservices.
Perfect.
I don't know.
Either way, tomato. And this, we're going to deploy it all to Amazon ECS. We're going to use Amazon ECS as our container orchestrator. If you're not familiar with what a container orchestrator is and how this all works, we're going to talk about that as well. We'll start with an overview of containers, ECS, the benefits, why use ECS, and then we're going to dive right into deploying our services. And we are going to use a tool, a CLI tool called AWS Copilot. This is the AWS Copilot CLI. This is what we call an opinionated tool. It's going to do a lot of the heavy lifting for us. So typically when you build environments and you want to build, you need an orchestrator, you need networking, you need security, all these things built in. To do it on your own requires you to know and understand all of those components and how to bring everything together. The AWS Copilot CLI simplifies all of that for you. So all you focus on is, here's my application, here's my container. Now, what category of workload type does this fit into? Let's get it deployed. So you'll see the simplicity as we walk through the workshop. And if you ever want to dive deeper into the concepts, again, ask questions. Brent will interrupt me as we're going through, and we're glad to dive in to anything that you folks want to hear about. Did that cut it, Brent? Anything I missed?
No, I think that's good.
Cool. And also, if you know, so
did you mention the Copilot track, or are we?
So I did say Copilot. I didn't mention this. So as we go through, you will notice tabs, and the tabs, when we get to the workshop, you'll see 3 tabs: Copilot CLI, or multiple, CDK, and some others. Every section in the workshop we go through, just make sure if there are tabs, you're focused on the Copilot CLI tab. So just to make sure you don't get lost. And one last thing I want to say just about whatever AWS account you're using, please be sure to, we're going to be playing around with things, deploying things. So obviously make sure this is an account that you're comfortable deploying a workshop into, and if you don't want to mix things up, I would recommend, if you're running something in one region, deploy this in another region. So just make sure you're not mixing all your eggs in the same basket here. Okay. So I've talked a lot, and I'm going to talk a whole lot more. So let's just dive right into it. So as I said earlier, we're going to be deploying a 3-tier microservice application. This is a polyglot application. And what that means is each service within our application is written in its own programming language. So we're not enforcing a single programming language across all the teams. This is kind of like if you were to envision, we have these small, 2 pizza teams, as we call them at Amazon, and you have a team that's building the front end service. Then you have teams that are building the back end services, each unique back end service. So the front end is going to be a Ruby on Rails app. The back end, we have a Crystal app, which is Crystal Lang, which I always tease Brent about this because I'd never heard of it until this workshop where he built this.
Me either.
And then a Node.js application. And what we're going to do is we're going to containerize all of them, and we're going to deploy them, and we're going to see them all work together. So let's just start with a high-level overview of containers. And if this is review for you, just feel free to go ahead and get yourself a cup of coffee, or go grab a bite to eat while we go through these. But as you can see, Brent's prepared, and so am I. So when we talk about containers, I think it's pretty widely known, or a lot of people will say this in the industry, is that I think it's kind of 3 basic things when you think containers. One, it gives you workload isolation and portability. And you get that isolation when you're running your container on the virtual machine. That container does not share its operating system in the sense of where your code's running with the other containers running on that host. You get the portability because you can run that container locally, okay? And that container image, basically when you're running it locally compared to when you run it in a real world environment, it's the same artifact. So your artifact is the same from your local workstation all the way to production environments. So if you think about that, Brent and I, we've been doing this a while, and prior to containers, I remember when I was working, supporting development teams and building CI/CD pipelines and making sure that the environments were, not only secure but highly available, easy to deploy, and packaged nicely. It was a lot of work, right? I had to think of RPM.
I was about to say, how many RPMs have you built in your day?
Oh, those specs. Ooh.
Yeah. So a long time ago, I actually worked at Red Hat. And so I, got very familiar with building RPMs. I don't want to ever have to do it again, and that only solves a little bit of the problem. So if you think about it, if you're coding a microservice, even a really small, simple one, you're probably going to pull in a few libraries, and some people, those libraries will pull in other libraries and have other dependencies. And you'll end up with, especially you'll see with the Node app, it's super simple, but it pulls in a litany of other, dependencies. Well, with RPMs, you simply list those dependencies. You don't include them, right? And what we really want to get to is a single artifact that can stand alone and not have anything else that it depends on. So the Docker image is that for us. And so we can actually package up everything that we need to run. And then all we have to have that we're dependent on still is the Linux kernel and the Docker daemon. And so we can take that, drop it in place, and we expect it to work the way that it works everywhere else. So it's literally the compile once, run everywhere concept brought to every language, not just Go and Java and some of the other limited languages that can do that. So that's one of the problems that Docker can solve for us, and it stays simple. Building a Docker image is really easy. The Docker file format is really simple. If you understand some basic Linux commands, you can mentally adopt the Docker file format and understand what's going on and not embarrass yourself doing it. So I think it's really cool.
Yeah, and it's the simplicity of that Docker file is what just makes it so great. Is packaging RPMs. It was a challenge. You had to be an expert, and I think the entry point, no pun intended here, because Docker entry point.
That's pretty good. I'm impressed.
But the entry point, getting into and understanding a Docker image when you first see it, it's very simple because the syntax is human readable, right? It's from this image, entry point. This is what I want you to do when that container, when you enter the container, like very specific syntax that's very easy to understand. So that, and imagine in the world when you're running multiple applications on the same host. That was such a great point, Brent, is if I want to patch one container, like think about having to patch a whole operating system that's running all these different programming languages that's running your applications, all the dependencies. You break one dependency, you break everything.
Oh man, I remember I'm going to practically give you my resume before this is over, I'm sure. But there was a point where I was working at Tumblr in the early days of Tumblr, and we were it was during like sort of the crossover time from Ruby 1X 1.9 to Ruby 2, and those things couldn't really coexist very easily on the same host. So we'd have to have fleets of hosts that could run one version of Ruby and fleets of hosts that could run a different version. You don't have to have that with Docker, right? Because Ruby goes inside, and so you can have a Docker image that holds different versions of Ruby based on whatever your needs are, and then they can run alongside each other. So
it's pretty remarkable. I mean, it's from those of us who have dealt with this in the past, you the pains that come with that, and the overnight patching and trying to figure out how to keep everything up and running while trying to maintain security and stability. So it's not easy, but containers have simplified that greatly. So
nice.
We talked about the benefits of containers. Now let's talk about ECS and what a container orchestrator is. So I came up with this actually on the fly at our last workshop, and Brent seemed to like it. When Brent likes it, that makes me very happy. So, but when we talk about an orchestrator, before we get there, let's think about how you run containers. So usually there's Docker, right? And you're going to do a Docker run, and then I'm going to run my container image. If I want to coordinate multiple containers on my laptop, I may use Docker Compose, right? That says, I want these containers to all launch at the same time, all have the ability to talk to one another. But what happens when you move from that to an environment where you need to run this, where it needs to be always up? If you want to ensure you have replicas of your containers, you want to say, I want 10 instances of this container running at all times. How do I do that? To do it on your own, it's not simple, right, Brent? I mean, thinking about how you would do that today without an orchestrator, what would you do?
Well, so you'd have to build it into your config management. And well, all right, so let's back up a step. Let's say before orchestration, a lot of people that are coming, the sort of graduation process is first you're just hand editing stuff and managing stuff. And if you have, I don't know, less than 10 servers, maybe you can get away with doing that. But eventually you realize, nope, I need something that can automate this for me. And so you start exploring config management. And config management is terrific. It got us a long way through the years. Maybe you're still using it today. It's definitely still prevalent. And it can do things like manage containers for you. So it can launch, make sure this Docker container is running, make sure it's on version or, has a certain hash, and make sure that if it dies, it gets restarted automatically. And you can do all that with config management. But the problem with that is when you need more servers, right? So it's not a matter of just run 2 of these on one host, or now let's make it 3. You can't dynamically adjust super quickly. You're always pinned to your workloads being on a server by server, mental model. Yeah. Well, with orchestration, what you can do is you can decouple those 2 layers, and you can say, okay, well, I have applications and they need to scale independently up and down. And then I also have compute. That's just a pool of resources. I need a bunch of CPUs. I need a bunch of memory. And then wherever I can, I'm going to Tetris these applications into that pool of resources and make them fit. And if my pool gets to be too small, or my wants for applications gets to be too large, I'll expand the pool and I'll just add more resources into it. And if it gets to be too large, there's a ton of waste, I'll contract the pool and make it smaller. So that's what orchestration is all about.
Exactly. And so what I was saying earlier is to kind of give an analogy, look at it as an orchestra. You have a conductor. So if I tell ECS, which is my orchestrator, that I want to have, at all times 5 instances of this container running, the orchestrator is going to make sure, just like a conductor makes sure the orchestra is all on time and the proper sections are playing and so on, it's the same thing. So ECS is going to make sure that you have those 5 tasks. If one dies, which is common, containers, we need to treat them as ephemeral, right? They are ephemeral in nature. So if one dies, things happen, as Werner says, our CTO, he's amazing. As he says, everything fails all the time. So we need to be thinking about that. We let the orchestrator handle that. We just need to make sure our application is resilient enough to handle and tolerate those types of scenarios. But
so I want to deviate from what we normally talk about, because we got some input from person that is just is a random looking hash to me, but we're listening. Here's the question: if time permits, will you please touch upon the comparison between ECS and EKS, if ECS also provides full orchestration capabilities across systems? So let's talk about that for a second, because I know we don't talk about it a lot. Amazon is one of the AWS is one of the few places where you have 2 major orchestrators that you can choose from. So how do you decide? And I'll tell you my thought process. And then, I don't know, Adam, maybe you can tell us yours, and then we can meet somewhere in the middle probably. But for me, I'm going to tell you the generic thing that I tell customers, and that is, if you know you want Kubernetes, then go for EKS. If you don't know, then start off trying ECS. And the main reason I say that is because there are trade-offs for each. And when you pick ECS, you're picking orchestration as a service. So what that means is we run the orchestrator for you, and we manage its features, and we manage repairing it, and we manage upgrading it, and all that stuff. And you simply fire API calls at it, and you give it some instructions, and then it carries those things out. EKS, on the other hand, is, even though we operate it for you, it's still more under your management. And so a lot of people want that. It's sort of like the difference between being, a regular car owner and being a race car driver. Like if you're a race car driver, you probably want to tweak every little aspect of your race car to get absolutely everything that you can out of it, and you're gonna be intimately familiar with the finest of details of how things work, or at least someone on your race car team is. If you're just a business traveler, you just want to walk into a rental car shop and walk away with a car, or drive away with a car, I guess.
Good point.
So you don't really care as long as it has four wheels and gets you where you want to go. And I'm not saying that ECS isn't a race car, or that it's only a rental car. Don't take the analogy that far. But the point is, do you just want something that works and that is provided for you, or do you want something that you can have more ownership of and you can tweak and optimize to your advantage? That tweaking and optimizing, though, comes with a lot more, that ownership comes with a lot more responsibility. You have to be there to fix it. You have to be there to upgrade it. You have to be there to troubleshoot it. So even though we'll operate the control plane for you, it's still on you to sort of make those moves. Whereas with ECS, we'll take care of doing all of those things for you as well. And then the second thing that I would say is, if you operate in more than one location, meaning like AWS plus your data center, perhaps, you might be exploring Kubernetes then to give you the same experience in both places. You can have the Kubernetes control plane in your data center, and then you can also have it at AWS. And that way you're sort of building your automation that'll look basically the same in both locations. That's a really strong reason to pick EKS. But if you're only in AWS, which a lot of people are, they're in AWS only, and you want to take advantage of just letting someone else, hand off that responsibility, and then you focus on the parts that matter most to you, which is what's inside the container, ECS is a great choice.
Well said. I want to just talk on 2 points that you made. Number one, the rental car thing, great analogy. And I think, if you were to compare it, it's you mentioned upgrades. With ECS, we enhance the orchestrator all the time. And then we often call this the control plane. This is that level that really orchestrates all the communication between all the nodes, the containers, to make sure everything's doing what it needs to do. So with ECS, those upgrades just happen. So unless it's something that needs to happen at the ECS agent level, which if you're running an ECS agent, that means you're running EC2 to run your containers. That just means you need to upgrade the agent, and that's that. But a lot of the times you don't need to do that, and you just get these updates out of the box. Whereas with Kubernetes, with EKS, when we update to a new version, you do have to think about upgrading your cluster, and it's something you have to think about. And it's not necessarily that's a bad thing, but it's just something that you have to be aware of.
It's toil. It's one of those things that you push. You're like, I'll get to that next week. I'll get to that next week. Right. And then before you know it, you get the notice that, hey, your cluster version is end of life and no longer going to be supported. And then you get the notice, we're going to be upgrading it for you and you can't stop us. And I'm not saying that we're that mean or that, that I made it sound worse than it is. But at the same time, it's something that like you do have to recognize that this is a task that is on your plate that you have to take care of. And there's not an equivalent task to that in ECS. So we'll just do it for you and you'll never care.
And so going the race car analogy, generally with a race car, you need a team, you need a pit crew that's going to maintain your race car.
It's true.
I
love that, man. This analogy is working out.
It's super good. And and look, so again, so with ECS, you do have it's AWS native, which I would say honestly with EKS we've done a fantastic job there too. So it just comes down to, what does your team know? As Brent said, if you're Kubernetes experts, go to EKS. You know Kubernetes. This is the API. You're familiar. Stick with that. If you don't know Kubernetes, you're launching your first container workload, or it's your 100th container workload, and you still don't know Kubernetes, ECS is a great way to get started, and also a great way to scale. We have customers on ECS running hundreds of thousands of containers.
Yes.
And these are customers that you're watching, them on TV.
That's right. You won't. Yeah, that's true. You won't outscale ECS. That's what I love about it. Now let's take the conversation just one level further and focus in just, let's say you've chosen ECS. Now you get to choose, okay, what tooling do I want to use with ECS? And you have some choices there. We today are going to talk about Copilot, but you also, Adam, give us 5 minutes on the CDK, and because that's another choice that you do have.
Absolutely. And so I think, we have opinionated ways to deploy to ECS. And, when we say opinionated, just to refresh again, opinionated means we handle a lot of the boilerplate stuff that you necessarily don't want to handle. And look, you can be an expert in it, but trust me, I know all the underlying components to build it. I always will go with Copilot first because I prefer opinion, because that means AWS, the team at AWS that's building this, they know better than I do. And there's a good chance they're going to be building in, good practices and making sure that things are done, in a good practice way. So with the CDK, you do get opinion, but this is a way to define your infrastructure, to define your applications and your containers as code. And when we say code, this is familiar programming languages like Python, TypeScript, .NET, Go. We just released support for. I feel like I'm missing one, and Java.
Oh yeah.
So with the CDK, so obviously it's a little more. This is if you like to define everything as code, the CDK is a way to do that. And it also has the concept of these constructs, which a construct is just basically a level of, I would say, of opinion. Okay, what level of opinion do you want and how deep do you need to go? So with CDK, you have high-level constructs that will build, for example, a Fargate load balance service. It's this much code, right? It's in Python, this much, but it builds all the assembly code needed to deploy that environment. And see, Brett can't even go far back enough.
Trying to fit it all into the screen.
And so now, and again, so I think this is where the community is driving us. And this is where our customers are driving us, is they want us to make things as easy as possible. But at the same time, they want to have those escape hatches in case they need to go deeper and build what they need or what they want, in addition to our opinion. So there is a section here on CDK, just to show you really quick. You can see this is my code here. Like I'm defining an environment as code, and I'm creating a VPC here with 4 lines of code, which is just one single method I'm calling. And
it's only 4 lines because you wanted it to be pretty.
It's true. I could fit it all in one line, but Pep 8 or
Yeah.
Violent didn't like that. But it's a great point. And that builds subnets, routing tables, NAT gateways if I want, all the things that I had to think about 5 years ago. Today, I don't have to think about those things. So that's the CDK. And now also there's other ways. If you're not comfortable with, doing it that way, you want to use like a YAML or JSON to define your infrastructure. There's CloudFormation. There's HashiCorp Terraform, which is amazing and wildly popular. And they have their own, it's called HCL, HashiCorp language, which is very similar to JSON, but it's prettier, right? But it's another way to build and deploy your environment. So I think the point there is you have choice, and choice can be overwhelming, but I promise you it's a good thing, because the idea is pick what makes sense for you and your team. Use the right tool for the job. I feel like Werner should recognize me for saying all of his quotes today. I'm gonna tweet at him. Okay, we've been talking a lot. I want to get into the workshop, and I want us to get going, because seriously, Brent and I could literally talk for 5 hours straight and not even know that we're just talking about the same thing over and over. So we're going to start here in the Start the Workshop section. One thing I want to point out is in the introduction, under ECS overview, take a look at, in your own time, take a look at these, this section. This explains what a cluster is, a task definition, all the different kind of resources that you use when deploying the ECS. So quick little explainers, but I highly recommend check that out when you have a chance. So we're going to do Start the Workshop here, and we're going to go down to Create a Workspace. And now here's where you can pick your region to deploy your environment. So I'm going to deploy in the Oregon region, but it's, you can deploy to Ireland, Frankfurt, Ohio, I think even, Virginia, wherever you are, feel free to pick that region. But it's recommended to choose one of these because we've tested it in these regions. And what we're going to do is we're going to create a Cloud9 environment. So we're going to click this link. It's going to take us to Cloud9. And Brent, what is Cloud9?
Cloud9 is a cloud-based IDE. And we love it because, it existed before Cloud Shell, but it gives us the ability to have a shell in our account, in our cloud environment. And it's probably one level higher than Cloud Shell because it gives us a text editor and stuff like that as well. Now that Cloud Shell exists, maybe we should test it out, running the workshop using Cloud Shell. But still, like, one of the things that I like about Cloud9 is that it's basically an EC2 instance with a web interface to it. And access is managed using the console. And when you go away from it, like you close that tab, by default, the setting is 30 minutes. 30 minutes later, the EC2 instance goes to sleep and you stop paying for that compute. I think you'll still pay for the EBS volume that's attached. And if you decide, okay, I'm ready to work on my project again, you can reopen that Cloud9 and it all comes back to life. You pick right up where you left off. And so I've gotten to where I use Cloud9 as sort of I have a bunch of different ones and they're all project based. So I don't have to have like one laptop that has, different directories for all my different projects and my different, keys and secret keys based on which project I'm working on. None of that. I just have Cloud9s and they all are how I access all my different stuff.
Yes. Yeah. So I love Cloud9. It's a lot of fun. Very easy to just get an environment and IDE up and running. Okay. So I created the instance. I closed out some of this stuff here. And another thing we should do, and I don't even know if it's in the workshop, but let's go to preferences. And then we're going to scroll down to AWS settings. And we're going to just disable the AWS managed temporary credentials. And this is because these temporary credentials, when you do it this way, there's a short TTL on them. And with Copilot, we're constantly polling, waiting back. And if that TTL expires, we don't get to see all the pretty output. So I want to make sure we see all that goodness. Okay. So now what we're going to do is we're going to create an IAM role, and we're going to attach it to the EC2 instance that the Cloud9 environment is running on. So it's a deep link. So it's going to be ready to go. Just click next for the permissions. And then it's already going to have administrator access checked. So we're going to click next. Then we're going to review. And then we're just going to name it ECS Workshop Admin. And this is going to give our EC2 instance that Cloud9 is running on admin access to our environment so we can deploy all of these resources that we want to deploy. Okay. So we did that. Oops. Let's close that. And now what we want to do is we want to go to our Cloud9 instance and attach that IAM role. Okay. So I click the link. Here's my Cloud9 instance. I'm just going to, you can right click it, go to security, modify IAM role, and then we're going to choose that ECS Workshop Admin role. And again, if you feel like I'm going too fast for you or I'm rushing through anything, please feel free to ask questions in the chat. But again, remember, this is all documented. So if I go faster or gloss over something, you can go back to ecsworkshop.com and read it, to the deep details on what I've done. All right, so I'm going to close all this other stuff. Okay, so we've created our workspace. We've attached the IAM role. Oh, look, we do mention that here. Good.
Oh, yeah. Yeah.
Okay. See, we're always thinking about it. Thinking about everything here. Okay, so now we're going to just install some tools. So we use JQ. This is a great way to parse JSON outputs. And then we're going to just do some prep for our credentials. So we're going to remove a credentials file. We're going to export some environment variables. These environment variables are important for the CLI, the AWS CLI, or our SDKs. There's a credential chain that it follows. So if an environment variable set that says my region is this, it's going to look at that and use that as the region. So let's make sure those are good. And it says, here's my region, which this is where I want to deploy US West 2. And so I'm going to be honest, I think we have some duplicates in here, but I'm just going to keep going anyways. And then, oh, you know what? See, let's do this. That actually, I think, was a little bug. AWS account ID. There we go. And then there we go. We're good.
Oh, interesting.
Yeah, I got to fix that. But that doesn't affect anything that we're doing today. Okay. So we're going to run this command to basically validate that we are running the role we expect. Okay. So this is just saying, do we have the admin role attached to our instance? Yes, we do. Okay. So if that doesn't work at this point, I would say don't go any further. Reach out to someone in chat so we can help you to make sure that you have this role attached to your instance. Last thing I'm going to do is I'm just going to increase the disk space on this EC2 instance. So by default, we get a pretty small amount of storage space. So we're just increasing it to, I think, 30 gigs, just to make sure we don't run out of disk space while we're playing and having fun today.
My Ruby container is big.
It's heavy.
It is.
But it's okay. It's okay. We can optimize that another time.
That's right.
Okay, perfect.
Put it on the backlog.
Exactly. It's in the backlog. Okay. So we're good. At this point, we're ready to go. So the next step is we are going to go to the deploying microservices to ECS chapter. And again, this is where we're going to deploy our 3-tier application. We're going to have a load balancer. That load balancer is going to route traffic to our front-end application. And then our front-end application is going to talk back to the back-end applications over service discovery. So, and just to show you again, what we should see is we should see this. By the time we're done today, we're going to see an application that has this image spanning across availability zones, telling us what container is responding in that moment. Live. Okay, so we'll start with installing and configuring tools. Again, This is the, we want to stick with the Copilot CLI tab. And just to address, there was a question in chat. I'm talking about the root volume on the Cloud9 instance, that EC2 instance, which I believe is EBS backed. And that is that is what we are increasing. Yes. So I'm going to copy and paste this. And so what we're going to do, we are going to install the Copilot CLI. We're going to update our AWS config, which is telling us to look for this AWS role, this IAM role that's attached to our instance, and so on. So let's just copy that and paste it in. Again, some duplicates there with installing JQ. And we're also installing the AWS CLI. So this takes just a moment. Perfect. Now let's just cat my AWS config file. Perfect. So just to make sure, you may want to cat home.aws/config. You can see my region set, my role ARN that I want to use is set, and how are we getting that is through EC2 instance metadata. So we are good to go here. So now we're going to proceed to the next step. And remember, stay with the Copilot CLI tabs. Okay. We're going to clone some repos. So these are our demo repos. These are publicly accessible, so you can check them out anytime. And we're just going to do a quick git clone on those. And then we're going to move on to the next section, which is deploying the platform. So you heard me mention earlier, I talked about opinionated tools and how they build a lot of the boilerplate. So when we first built this workshop, when Brent first built this, we had the concept of, we built the platform, which was we built a VPC, we built a load balancer, we kind of built all of these components in advance for us to deploy our services onto and to deploy our services onto that cluster and so on. Well, nowadays, this still could be relevant. There's still organizations where there's a team that manages the network and the VPC and so on. But in this case, for the workshop, we don't need to think about the platform because Copilot is an opinionated tool that's going to build the platform for us. So all we're thinking about in this workshop is, how do I deploy my containers? I just want to get my containers deployed. I don't have to be an expert in VPC today. We're not going to do a deep dive in networking. And I bet you're thankful for that. So, because I
for one, am thankful for that.
So we're going to just proceed on. But if you see here, we tell you, depending on which path you go down. And by the way, the CDK is the same. You don't have to build the platform. But with the CDK, we kind of took that use case where you have a team that may be managing certain environments like the VPC and some other components. And then we talk about how you can import those. But with the Copilot, we're letting the opinion, we're letting the AWS good practices do the building. And me, who may not know all of those good practices, rely on AWS to handle that. Okay, so now we should be in our front end Rails app. Okay, so this is where we're going to deploy our front end service. And, again, I showed you that image. The goal is we want to get to that beautiful image showing our front end service as responding. No, Brent, it is beautiful. It's fantastic. Don't you laugh at that. You did a great job with that.
Oh my gosh.
So we're gonna CD into our front end service, and then we're gonna run a Copilot init. Now with Copilot, there's two ways I can approach this. One, I can do a Copilot init. I can pass in all of my parameters as flags to the CLI command. But if I don't want to do that and I want to go off of a more guided experience, Copilot has a super rich UX, and it really makes the deployment process incredibly easy. So all we're going to do to get started is run a Copilot init, and it's going to ask me a series of questions to get started. The first thing is, I want to name my application. So I'm going to name my application ECS Workshop. So with Copilot, we have the concept of an application. So look at that as like the umbrella. The application is ECS Workshop. And then within my application, I have environments, which is my test environment, staging, prod. And then I have my services, which my services are my, my microservices that are long running, or they're, scheduled jobs, whatever that is. So we're going to name this ECS workshop, and then it's going to ask me what type of service do I want to build. Well, I want to build a load balance web service because I'm building my front end. So what do I want to name this? So we're going to name this, let me just make sure so I don't forget. We're going to name it ECS demo front end. And then it's going to ask me what Docker file. So Copilot navigates through my directory and finds my Docker files. And it says, hey, do you want to use one of these? Because I see you have them. And if I don't want to use one of those, I can use an existing image from like an upstream repository if I wanted to. But always good practice to not just use the latest, upstream image that you're not, securing and hardening. Make sure you're hardening your images. And then we're going to hit OK. So we selected the Docker file, and that's it. Now, Brent, do you notice here that it says, OK, great, we're going to set up this load balance web service listening on port 3000? Did I tell it anywhere that port 3000 is where I wanted it to listen?
I don't think you did.
I didn't. And that is, again, what's so amazing about this tool is it looked at my Docker file. So not only did it find my Docker file, but then it introspected the file. And it said, I see you have an expose statement. So in a Docker file, you can say there's an expose statement that says, here's the port I want to expose this container on. So it saw we're exposing port 3000. So it knows that when it deploys this load balancer, my container is still going to run on port 3000, but the load balancer and our front end is not. It's going to run on 80 for the demo. Now, of course, if you're running a production web app, it should be 443 HTTPS, which Copilot can do as well if you have a domain. But yeah, so it figured all that out for me. I didn't have to tell it anything else.
That's really cool. And that's the kind of thing that, fast forward a year or two, there will be more things that will become like obvious patterns that we can start to incorporate into future versions of Copilot. And we can just make some assumptions based on what we see inside your code, or see inside your Docker file, or inside your repository. So I think this is the kind of thing where the tooling can really start to make your life easier.
Yes. And so, okay, it did ask me if I wanted to deploy a test environment. So I said yes. So now this is going to build the VPC, all those things I was talking about. It's going to build them for me. IAM roles, security groups, all the things that you need to think of, routing tables. I could just keep going. I don't have to think about that. It's going to do that for me. There was a question in chat that I want to address that was around, so is the container running in a private subnet and reaches the ALB through a NAT gateway or internet gateway? So let's talk a little bit about that. So I made the choice by default. Copilot will deploy my services in a public subnet. Now, those services are protected. They're not wide open to the internet. I do have the option, which was just recently based off of customer feedback, I do have the option to choose a private subnet. But I will tell you, Brett and I, we've talked about this. When 5 years ago, we would have said, no, you don't run anything in public subnet. Everything's private, right? Yeah. Only your load balancers are in public. However, we've evolved and we've come a long way. And from a security perspective, I control access to my containers through security groups and attaching public IP addresses to them, right? Yeah. So if I don't do those things and I keep those closed, they're not publicly accessible. Yeah. So we're on top of that, we're saving money because we're not using NAT gateways. Right. Right. So I don't have to go out on the internet through a NAT gateway. I can just go straight out through the internet gateway.
Right. So that's an optimization that you, like Adam was saying, you can sort of opt into or opt out of. And, I have grown comfortable running workloads in public subnets because I recognize that the way you would exploit them doesn't go away by moving it to a private subnet. The one thing that, if you're on some you're in a shared VPC on an enterprise account or something like that, where you might have a limited number of IP addresses. That might be a situation that drives you more in the direction of putting more work into private subnets, because you have a bigger IP pool that you can pull from. So these are some trade-offs, and you can choose your own path using Copilot. And it's cool that you have that choice. In our example, we're going to follow the public subnet path, but you can certainly go the other route, and it should work as expected. Now, we've had a couple of other messages come in. I'm a little confused between the Copilot CLI, CDK, and ECS CLI. And then second question, is there a separate binary installer for Copilot CLI if I'm running from a standalone EC2 instance similar to ECS CLI? So let's just talk about that real quick. ECS CLI was our first CLI that managed ECS work, and Copilot is sort of the next evolution of that. So it includes an opinion for sure, but we want you to consider managing your work using Copilot, and it can, for the most part, replace ECS CLI. So is there an installer? Yes, absolutely. You can install it using, we use GitHub. It's a completely open source project. We use GitHub. There are releases. And then, on a Mac, you can brew install.
Or Linux.
Oh yeah, I forget Linux can do homebrew. But yeah, there's Windows binaries, Mac binaries, Linux binaries. So you can definitely install it using your preferred flavor of operating system. We kind of see it, like I said, as the replacement for ECS CLI. So definitely think of it that way. The CDK is a higher level project than that. It's a way of managing many AWS services, perhaps even all of them to some degree.
Yeah.
So, basically anything that CloudFormation can manage, the CDK can manage to some degree. So it's more than just ECS. However, you can definitely manage ECS stuff with it. So you can think of it as more akin to what you would do in CloudFormation, just a lot simpler, a lot easier.
Yeah, and again, I can write, so it's in code, so everything's defined in code. I can write unit tests against this. I can, there's so much more power that I have to test my code, to deploy it, and so on. So the CDK, I would say, is just, it's if you are familiar with programming, you're a programmer, you're a developer, CDK is fantastic. I will say, I do think there's a world where Copilot and the CDK can live together. And, I think it just depends on, the organization structure and so on. But
yeah,
I won't get too deep into that. But there is, I believe, a workshop after this on intro to CDK. So if you're interested in the CDK, check it out. But, imagine if you're deploying a bunch of stuff, Lambda, RDS, there's just a bunch of stuff you need to have more control over it. The CDK is a pretty good option.
Oh, totally.
But Copilot has the concept of add-ons. So you can always use CloudFormation in an add-ons template as well. So there's choice.
For sure.
And so if you're in the chat, you may have noticed we have Austin in there. Austin is actually one of the software engineers on the Copilot team. So he's answering questions. But yeah, so just going back to that question of the networking, you can also bring in your own VPC. So if you have an existing VPC, you can pop that right in there into your manifest. So
nice. Can we say, is it safe to say Austin has forgotten more about Copilot than we have ever known?
For sure. For sure. He yeah, so and the Copilot team's super amazing. If you ever want to just talk to them, GitHub, they're very active on GitHub, as well as Gitter, which I call Jitter.
I was
And
couldn't
Brett
wait to
gets so
see
mad.
which way you were going to go with that.
Brett, Brett gets so mad. But those are great ways to reach out to the team. And of course, on Twitter, you can always reach out to Brent or myself. But the whole Copilot team is on there, so you'll eventually see them. We tweet a lot with each other. So
Well, let's recap real quick. What's
yes,
happening right now? So we've told it to deploy our first environment and our first application, and so it's walking through building out. You can see the list. It's building out the IAM role, the ECS cluster, security groups. So there's a lot of like infrastructure-y things that it had to start with first. Then it went on and it built our container, and it does that locally. So we have to have Docker locally, but it also had built for us an ECR repository. And so once it built the container, it pushed it to ECR, to that repository that it built for us. And now it built a task definition, a service definition, and it's deploying that out onto ECS. Can we switch over to the ECS console and let's just break down the difference between a task definition and a service definition real quick?
love that. Yes. Am I in the right place here?
Because now they should both be there.
Yep. So we have my cluster here. I don't have any. My service isn't deployed yet, I don't think. Let's go to task definitions.
Yeah.
It hasn't built my task definition yet, I don't believe.
Oh, really? Okay. Well, let's. Okay.
What is this? I don't even know what this is here. Anyway, I don't know what I'm doing in my own account. But let's talk about that. So I think what it's waiting on right now is it's actually building that application load balancer. And by the way, some of these things you may notice it's taking a few minutes. A lot of this stuff is just one-time actions. Building a VPC, building a load balancer, all that stuff takes a few minutes because there's a lot that's going into building all this behind the scenes. Once this is all built and then we deploy again, it's just building our container image, deploying that container image. Should we talk about a task definition? Is that?
Yeah, and I just noticed there's another message. I'm still confused. What is the CDK? Is there a web page we could pull up that's a
Absolutely
one-hit CDK?
Yes. And here, I'm going to post it here. Actually, let's see. We'll put it in the banner here.
CDK, so this is the unofficial not go-to-market messaging. For me, it's like the next evolution of CloudFormation. So I'm sure that there's someone on the CDK team that would be red in the face at that summary, but that's just that's the way I bucket it. I think of it as infrastructure as code, but using real code, a real programming language. And then it also includes some lightweight opinion. But instead of like what Copilot does is we know you're going to be running a Docker container using ECS, and it's either going to be a front-end service or a back-end service or a job. And so because of all of that, we can like just start from that perspective, and we can work backwards a long way, all the way to all of the infrastructure necessary. The CDK, on the other hand, would be more like, I need an S3 bucket. And so it'll help you build an S3 bucket, with all of the good practices around that. And then if you also need an SQS queue, it'll help you provision one of those with all of the good practices. And if you need to link those two things together, it'll help you do that. And then if you wanted to build a higher level construct that always provides an S3 bucket and an SQS queue and a whatever else you might want to include. You can roll all that together into a construct and provide it out to, the rest of your company or as an open source model, etc. So CDK is infrastructure as code, and Copilot is more like a CLI that can manage your containers.
Yeah, and so like to get Copilot to build all these things, I didn't have to do anything outside of a Copilot and init. But with CDK, it's a little more advanced in the use case, because I have to at least have some awareness of everything, of what I'm trying to build, if that makes sense. So like I have to define, a VPC. So I have to import the VPC module, and then I can use all those methods within it, but it's all code. So there's helper methods built in. It makes that experience a whole lot easier because it's a programming language. It has strong typing. So if I'm typing like VPC, I use the VPC module, it's going to give me all these options.
Code completion. How I want to
define it. Code completion. Yeah. Which is a big deal. So, and again, it really, there have been a lot of folks who, myself included, who used to use other ways, other open source projects to define their cloud formation as in a programming language, because we didn't want to just have to build everything using, 1,000 lines of JSON can be very overwhelming. So that's, I would say, one of the big differences. So in that time while we were talking, it deployed our service. It deployed created a task definition, attached it to that service, created all the stuff, the load balancer and all that. Now, Brent gets mad at me because the way I start this workshop is I deploy it broken, and we're going to go in and fix it. So what I'm going to do really quick is I'm going to fix it, and then we're going to go back and actually look at all these things. So, okay. So what we did was, and if you want to go ahead and do it, you just scroll down to the create a CI/CD pipeline section, expand here if you don't want to create a pipeline, but you still want to fix the service. And then what we're going to do is then run a Copilot service deploy. And what this is going to do is it's going to build a new image. And let me actually take a step back. So when we wrote this app with Copilot, at the time, the version of Fargate that this was running on didn't have the ability to talk to its task metadata endpoint and get the availability zone it was running in. And one thing this application does is it tells you what availability zone we're running in. So what we're doing is we're creating an IAM role, and all we're doing is outputting that, or I'm sorry, a policy. I mix these up. We're creating an IAM policy. We're putting it in the add-ons directory in Copilot, and Copilot's going to take that policy that I created. It's going to attach it to my service, my task. And when when the service redeploys, it's now going to have that new IAM role with that policy that's going to allow me to make these API calls, which was EC2 describe subnets. So go ahead.
And this is all happening because you're able to customize using add-ons.
Yep.
So this is a bigger question that comes up from time to time is, well, what if I want to do something, that Copilot doesn't have built in? Well, there's this concept of add-ons where you can take a snippet of CloudFormation. So instead of the 1,000 lines of CloudFormation that you normally need to make everything that's happening today happen, you just have, a snippet of CloudFormation that you can apply that'll do the one thing that you need, and it'll get incorporated into the bigger picture and, kind of not joined in the appropriate manner.
Yes. And so one other thing, so not only is Copilot the tool I use to deploy my environments, to deploy my containers, it's also a day two operational tool, right? So I can use this for operational, just insight into my environments. So it has a couple commands. So we talked about an application. So I could do a Copilot app show. this is going to tell me, here's your, so remember I named it ECS Workshop. Here are the environments I have deployed. So as you have more environments that you deploy, test, staging, prod, I'll see them here. I can see what services I have deployed, as well as what pipelines I have deployed. I'm not going to deploy a pipeline in this workshop, but I highly recommend after this workshop's done, you go through the create a CI/CD pipeline section. It just works with GitHub. You have to create a key and so on. But it's super cool because if creating CI/CD pipelines is not super trivial, and Copilot literally does all of that for you as well. All you do is a Copilot pipeline init, and it builds a pipeline, and it will build that image, take that image artifact, deploy it all to all your environments in a single pipeline. So I can do, so let's actually do Copilot service ls. Let's see what services I have. So now I'm going to just do a Copilot service show. We can see here's my front end service. Here's the environment variables. Basically, Copilot gives me a default set of environment variables that are accessible to my containers. But here you can see the load balancer for my environments. I mean, it's very easy to get what you need all from the CLI. And I could do a service status, which will show me here are the tasks you have running. Here was the last update. And you can see we're going to be removing one task here soon because we have an active deployment, which was 33 seconds ago.
That's kind of cool, actually. I don't think I've ever seen -1 pending. That's pretty cool.
Yeah. And, oh, no, Siri, not you. And so another feature we added, which is a relatively new feature, which is called ECS exec, which is through Copilot. Okay. This is a way for us to actually gain access to our containers. So I can run Copilot service exec, and this will actually shell into my container that's running right now. Now, I do want to just quickly say, we recommend in production, you're not accessing your containers. These should be untouched, ephemeral, but of course there are times things go wrong. You need to see what's going on in real time. This gives you that ability. So you can see I'm in my container now. And the last thing is I can do Copilot service logs, and then I can do dash. Did I do that right? Sure. Yep. Logs. Do a dash follow. So I can actually live tail my logs here too to see what's going on with my service. Okay, so now what I'm going to do is I'm going to move a little bit faster, but as you can see, I fixed my application. Here it is. We're running in one availability zone. And now I'm going to kind of move in rapid fire here because I want to get everything deployed. Okay, so I'm going to move through the Node.js backend and then the Crystal backend, and I'm going to deploy them. This is where it may feel like I'm going a little fast, but I just want to make sure you see it all happening in real time.
Yeah, that's fair. So just to summarize, we've done one deployment now and it's built out our infrastructure. And now we're going to go ahead and do a second and a third. And we're going to go pretty fast because it's the same workflow, just repeated. So we'll point out, though, the one area that's different is what here, actually. We're going to pick, instead of load balanced web service, we're going to pick backend service. And the biggest difference, I think only difference, is that the first time we made the choice, we were deploying something that a load balancer was going to manage the traffic for us. But these two APIs are they aren't meant to be publicly exposed. They're meant to be only accessible within the cluster. The front end is going to talk to them. And because of that, they're just back-end APIs. And so there's no load balancer necessary. So that's what's happening here.
Oh, cool. And so I think actually, because I have I can't deploy them simultaneously here because we're updating a shared template. So I'm just going to deploy this, and then I'll deploy the Node.js one.
Yeah, and I think that overlap that you just ran into is really brief.
Yeah, this was just me moving too fast. GS demo Node.js, and then we're going to choose our Docker file. And again, yep, as Brent said, choosing a backend service, my front end's going to talk to these. So what we'll see in just a few moments is it's going to, just like it did for the front end, it's going to build the Docker image, push that image to a repository in ECR, Elastic Container Registry. This is our fully managed Docker registry service, or container registry service, geez. So that's happening. And while this is all happening, don't let that red scare you. It's okay. That's just Brent's code.
I know it's full of red. Actually, I'm impressed that that's all that we saw.
So what I want to do is so I'm going to do this. What I'm going to do is I'm going to open up this manifest. So you go to the Copilot directory in your repo, and then you open the manifest. Here's where you can see all the things, like kind of the defaults that came with it.
Can we bump that font size up a little bit?
Yes. Does that look okay?
I think it does. Yeah. Oh, that looks good.
Okay. I figured out a new way to do this, by the way.
That was, yeah. You're going to have to tell me how to do that later.
So you can see we have environment variables here set. This manifest, though, is where I can add basically any additions I want to add to my my service. I can modify the manifest here. And so one thing I want to do is I want to change the count. So here's another really just crazy cool thing about Copilot is I can, instead of this, I can actually have auto scaling set. So I forget the syntax. I actually got to look at the manifest here.
I think, wasn't it in the comment section?
Here we go. I can do range. So you look here. I'm going to put all of these in here because I want to just show what I can do. So we're going to go back here. This is not set to Vim mode. It's going to make me a little crazy if I don't have my Vim bindings. So give me a moment. I promise 2 seconds here. Key bindings, Vim. Whew, game changer. Okay.
We were about to see Adam's head explode.
Okay. So now you can see, here's all the options I have. So auto scaling for my service, I can set through Copilot. So I can say, here's the range that I want you to scale from. If I want to scale on requests, so if I know my front end service, its tipping point or its point where I need to start scaling out is when I hit 10,000 requests per second, I can set that here. Or response time based on my application response time. These are just default out of the box. Copilot gives these to you. So I could also set my CPU and memory based on how I want to scale. But for now, what I'm going to do is I'm just going to statically set my count to 3. And I'm going to scale these up. The other thing I want to point out, Brent, that I know gets you really excited is around Spot.
Yes.
So let's add.
We're going off script here. We're gonna
completely off script.
We're doing this live.
I'm gonna do this. I'm gonna say I want 3 Spot containers running. Brent, tell the audience what is Spot and why are you so in love with Spot?
Oh wow! I mean, wow. Okay, so
it was a lot. I'm sorry, I threw it all.
It's a lot. Like I can't just I'm gonna do my best to just summarize that. So I love Spot because Spot it's using our excess capacity and getting compute at a substantial discount. And you might be familiar with Spot when it comes to EC2 instances, but we also offer Spot for Fargate. And so this is deploying out onto Fargate just like before, but instead of paying the normal Fargate sizing, you're actually getting the exact same sizing, but at a substantial discount. And the trade-off is just like with EC2 instances, at a 2-minute notice, we can reclaim that compute from you. So that decision making all happens on an availability zone by availability zone basis. So if you're running in any kind of resilient mode, which, multiple containers running across availability zones, you mitigate that risk just a bit. So this is something that you could consider doing to help cost optimize. And some customers run 100% on spot because they've gotten so good at staying up. And other customers will figure out, okay, well, what's my critical path? And they'll keep their critical path on the on-demand rate, but then their non-critical path services that they can sort of degrade and be without, they'll put those on spot. And so there's all kinds of cool approaches, and it just gives you another dial that you can optimize and figure out, like, how can I do this as efficiently as possible.
Yeah. And so with Copilot, it gives you the option to run everything on spot. And I would say at a minimum, even if you're not comfortable with spot in production, for your test environments, take advantage of spot. You're getting
Oh yeah.
I think it's I don't even, you may have said this, I think it's up to 70% cost
I
savings.
didn't want to quote it because if we do post this recording, in the future, it might be something different. So
whatever it is, it's
as of today. Yeah, exactly.
Yeah. But also Copilot has the option to do spot. So there's a flag in your manifest file that you can say spot from. So spot from means I want to have a baseline. I want to say so in this example, we're saying, let's say this spot from was 5. I'm saying my first 4 tasks, it's either 4 or 5. I think it's my first 4 tasks. I want to be on demand Fargate, not spot. But everything after, deploy it to spot, because I know I need this many baseline tasks running. Okay. But anything after that, it's okay. If somehow, they have to be reclaimed because capacity is needed, that's okay. I still have my baseline running. And then when that capacity is freed up again, we can deploy back out. So kind of exciting.
Yep.
That was a really nice feature to see added to Copilot. So let me just update what I've done, because I kind of went rapid fire there. So I'm deploying my 2 backend services. You can see once again, I deployed them broken, and I fixed them by adding that IAM policy to my add-ons directory for each service. And then we just did a Copilot service deploy. So the first deploy was broken. The next deploy coming in, we should see now our services all talking to each other and showing the proper availability zone and so on. And I also scaled my front end application to 3. So I wanted to make sure I had 3 tasks running. So that's what I did. So if I just quickly go back here. So we did this with the Node.js backend. We did a Copilot init, answered the questions. We added that IAM policy to the add-ons directory. We updated our manifest with some environment variables we needed, and we deployed. And then the same with the Crystal backend. So like I said, this is going to take a minute, but you can already see, here we go. So our new application, we fixed our backend services. We redeployed them. You can see it's right now, my front end is spanning across multiple availability zones. And you can see I have 3 running there. So 10, 0, 1, 64, and then I think we have 76 and 47. So 3 front end services are running, and they're all talking to the single backends. And then I can change the count on those backend services so we can have more running as well. But that's pretty much it. So I want to just kind of go back in time here. We started this with, we don't want to have to define and build all of this boilerplate, right? All of the VPCs, all the kind of underlying components. We don't want to think about that. But what we do want to do is get our containers. We have our container images. We want to get those deployed, but we don't want to worry about all that other stuff. So Copilot was able to take us from, here's my Docker image, took us through a guided experience, said, what type of application are you deploying? It was able to find my Docker file, introspect my Docker file, and find out what ports I'm exposing, as well as health checks, by the way. We just don't have any, I don't think, defined here, but it does help with that as well. And that was it. I had my container images, and Copilot did the rest. It built my images, built my environments, and then deployed. And I can go a step further. I can create a CI/CD pipeline, which, we have about 30 minutes. I may just do that, depending. But what I think I want to do is probably take a moment to allow everyone to catch up.
Yeah, let's in fact, let's take a break. I'm going to pop up the survey information in case anyone is caught up and feeling pretty good. And then we're going to go off camera for about 10 minutes, and then we'll come back and we'll be here to answer any questions that anyone has. I know people have been asking questions in chat. That's great. So if you want us to discuss by voice or show anything that you want to see again, we'll be back in about 10 minutes. And real quick, one of the questions, what is Crystal again? I missed that. It's just a random programming language that I chose because I wanted to be able to just show that you can put anything in a container. And so just like Python as a language, Ruby as a language, at the time, everyone was talking about, some Go utility that they wrote. So I didn't want to use Go because everyone else was. And so I picked Crystal. And so I just, wrote the app using Crystal, and that's the only time I've ever used it. So that's what it is. But anyway, we're going to take a break. We'll be back. I'm going to pop up the survey. Definitely take that survey. And then if you have anything that you want us to follow up on, we'll be back in about 10 minutes.
Yes.
Are we ready? Awesome. Oh, I know.
We have fun here, don't we?
I have too many chat windows open. I figured it's just better to say it by voice.
Yeah, I agree. I agree. So while we were waiting, I decided to just scale up our back end services. And the one thing I wanted to point out was when I do a Copilot service status for our front end, we can see the type of Fargate task we're running. So you can see my front end services are all Fargate spot.
Nice. That's really cool.
Whereas with Crystal service, let's see, can I make this prettier? There we go. It's everything's chewed up here, but it's just,
well, its capacity provider is just that must be like the default.
Yeah, it
when
usually
it's just
shows
dash.
Fargate.
Well, okay. Are you sure about that?
I don't know. Maybe not. Maybe I'm crazy. I thought it did. But anyways, you can see here's and one other thing I wanted to mention was about health checks. So if you look here, you can see the health is unknown in our front end. That's because we didn't define a health check. So it just creates a default health check. Yeah, it's okay, Brent. It's okay. These things happen.
It's on the backlog.
It's in the backlog. Right. We'll go over it in our next backlog review. But for the Crystal service, we do have a health check defined in our Docker file. So Copilot said, I like that. I'm going to use that for your health check. And so it did. So we actually have this health check implemented in our ECS service. So you can see it's running and it's showing healthy. And then.
So we had a question come in. How did you fix the role in the manifest.yaml? So let's go over that.
Okay. Perfect. Yes. So Copilot does have, I just want to talk about add-ons again. So there's the concept of add-ons with Copilot. So remember, Copilot is opinionated. It can build these, it builds a lot of these things for you. But there's going to be times where there's something you may need to do that's not covered within the Copilot, opinionated tool. And so an example here is my application. I need to make API calls to EC2 because we're running in a subnet. There's an API call that I call EC2 describe subnets. So I can't do that because remember, let me just say that in AWS, when you deploy something, generally by default, it's least privilege access. So we're not just giving you, access to everything. You have to explicitly say you need this access. So this is an example where I want to just make this API call. So I need to create an IAM policy. So because my container needs that IAM policy attached to it so it can make that call. So if you go to the Copilot directory in the service, ECS demo front end, there's an add-ons directory. So if I go to add-ons here, this is where I created this task role YAML. And here is where I'm creating my resource, which is this IAM policy, and I'm defining it as CloudFormation. So, CloudFormation is just a way to define my infrastructure, in this case, as YAML. And I'm saying, here's my policy, and then I output it. So in our documentation for add-ons, we do guide you as to what to do to make sure that if you need this exposed to your container, to your task, that you follow this particular pattern. So here, I'm taking this policy and I'm outputting the Amazon resource name for this policy. And by making this an output, what Copilot does is it recognizes you've created an IAM role, you've outputted this role ARN. Now, Copilot is smart enough to take that policy and attach it to that role. I keep saying role ARN. It takes that policy ARN and it'll attach it to the role that your tasks run with. So now I have that permission. So we created the CloudFormation in the add-ons directory. I didn't have to do anything in the manifest. And I just did a Copilot service deploy, and it created this CloudFormation template for me. And then it attached that role, that policy to my container, my task role, which with ECS, there's the concept of, you have the ability to attach IAM roles to your tasks. And a task in ECS, a task is a container or a collection of containers that all run as a part of the same task. Go ahead.
That actually brings me to the next thing I wanted to make sure that we went back and walked through is now let's go back to the console. And let's just look at everything that has been built. But let's start with the task definitions and then the service and stuff like that.
Perfect. Yeah, so since we're talking about the front end, let's stick there.
Okay.
So the task definition is essentially, this is your representation of how you want your container or containers to run. That can be confusing when I say that, so I want to just go a little deeper there. So when in your task definition, you define, this is my container. So we know we have our front end service. This is our Ruby on Rails app. Here's the port I want it to run on. Here are the environment variables I need, and so on. But there are times where you may want to run another container or other containers alongside this container here, this front end container. Let me give you an example because I feel like it's confused. I'm making it more confusing than it is. If I want to have I want to log to Splunk. We at my organization, we use Splunk for a lot of different things, but logging is one of them. So I want to be able to take the logs from my container and send them to Splunk. What I can do is add another container here, which is called like a sidecar. And that container can ingest the logs from my application. It has access to the local volume. They're all able to talk to each other on localhost, and they're right next to each other. So it's ensuring that every time a new task comes up, that all the containers defined in that task come up together, and they're located right next to each other, right, or within on the same host. They're all very close and talk to each other. And so it just makes it a lot easier. Another example would be, I want to have a Redis cache that lives right next to my container at all times. I would just add that to this container definition in my task definition. And every time a new task comes up, both those containers come up and they're talking to each other. Does that make sense?
Yeah, absolutely. These are all services. You could think of all these services as being able to talk to each other over localhost. So Sidecar is the perfect use case for multiple containers in one task definition. You might have your main container, but then you might also have something that handles log parsing and forwarding, something that handles collecting metrics and shipping those off where they want to go, something that maybe is a proxy for routing or static images or something like that. So in a deployment, you want them to all go out together, and you want them to all get replaced together as you roll your containers to the next version. So that's how you can think of that, as it's one big unit that operates as one, and they can communicate with each other over localhost. It's not, I want 2 copies or 3 copies or 4 copies. That would end up being multiples of this task definition, whatever is defined inside.
Bingo. And those, you set, like within your task definition, you set your resource allocation. So I need, 1 virtual CPU and I need a gig of RAM. And then all those containers underneath, you can say how much you want to carve off for each of those containers, but they all basically consume those resources together. But another thing to make sure that we don't confuse here is our 3-tier application, I'm not defining front end, back end services all in one task definition. Those are 3 separate task definitions.
Yes.
So
exactly.
Very specific. So you have your task definition, which defines how do you want your container to run or your containers to run, right? Now, at this point, I have a choice. Do I want to just one-off launch a task? Maybe I just want to, just launch something to do one thing. Or do I want it to be long running? So if I want it to be long running and I want to ensure that the scheduler, the ECS scheduler is keeping track and making sure that I have a certain amount of these tasks running at all times, that's where the service comes into play. So let's go into our cluster and let's drill down into our front end service. And now this is where we define, I want this many instances, or I want to be able to scale in and out based on these metrics for this task definition at all times. So the scheduler's job is to be the brains to say, you've defined your desired state for this task definition is to have 3 running at all times. We're going to make sure that happens. So logging, as far as like, it's just going to basically ensure that that task is running as you expect at all times.
Yeah. So with tasks, you can think of them as one by one by one, but then collectively, they're all the same thing. This is all ECS demo front end, no matter how many you have. And so many times you want to do something to all of them. Maybe it's you want to upgrade them, you want to move them to the next version, or you just want to see logs, and it's from all of them. So that's when you operate at the service level. And so having that sort of abstraction means that you don't have to know, I need to SSH into each host, I need to gather this information off of each host, I need to aggregate it all together. You don't do any of that. It's all done for you by just choosing to examine things using the service instead of using the tasks.
Yeah, exactly. And, out of the box, so this is another thing with, Copilot with ECS is just deeply integrated with other AWS services. And so an example of one of those integrations is with CloudWatch. So out of the box with Copilot, with ECS, you're getting CloudWatch logs. So all your application logs are going to one place. And your CPU and memory utilization metrics are available the second you start deploying. So you can see I'm able to track CPU utilization, memory utilization across my tasks, all here in the console. But of course, with Copilot, I can do that from here as well.
So there was a question in chat, any good material for how to trigger Fargate tasks from SQS? And I said, I think step functions can be a good way to manage this, but do you have any thoughts, like if you wanted to be a little bit more event-driven, or at least queue-based? It's not quite event-driven, but it's queue-based.
Yeah, I think there's... So when I think of this in 2 ways, if you really want like event-driven, you can trigger Fargate tasks off of events, but with SQS, I would recommend if you want to just be event-based, Lambda is a really good approach there. If you want to have a Fargate test that just polls an SQS queue, there's like long polling. There's ways that you can be really efficient with how you poll SQS. This, I would probably just, I would say the CDK has a pattern that's called Fargate. Actually, I'll tell you right now, AWS CDK, ECS, SQS. It's a queue processing Fargate service. So this is a way to create a service. It'll be long running. It's constantly going to pull. You then write the logic to pull your queue, but this will create a queue, sync everything together. But this is through the CDK. What would be nice to see, and if this is something that maybe you want to see in Copilot, this is where I'd suggest go to our GitHub, the Copilot GitHub page, submit an issue, say what you're looking for, and maybe this can eventually be a pattern.
Yes, exactly. These kinds of things start from customer feedback. So Red PJ662, go to the GitHub page and open an issue and describe, like, what is it that you either do or are trying to do, and let us, I'm sure there'll be some back and forth where we ask you some questions, but ultimately we'd like to be able to design a feature that can fit, a lot of use cases. And this is another common use case that I think would be really cool for Copilot to address down the road. So, but it all starts with us gathering feedback from you all.
100%. Yeah. So that's pretty much it for the workshop.
So let's just recap. What have we done? We started from nothing with a blank AWS account. And by the end of the day, we had our 3-tier microservices application. See, I fell into that trap too. Deployed. It's auto scaling. It is self-healing. One of our services is using Fargate Spot. That's pretty fancy, not part of the workshop. And we managed it all using an open source CLI called Copilot. And we get day one functionality. We can build it all, but then we can also operate it. And you'll notice that until the very end, when we just went and explored, we never even really used the console. So this was all developer focused. This was all done directly from the command line. Then there's a whole like phase 2 to all of this, which is building out the pipeline that connects your GitHub repo or code commit, or sorry, Bitbucket. What is it? What's the other one?
I think it's code commit and
GitHub and code commit.
Yep.
Okay. I know it's GitHub. That's the one I use. So, but it connects that and builds a pipeline for you so that you can go from code all the way to deployment just automatically and never have to interact with it if you don't want to. But you can still use the Copilot CLI to get logs, to check on things, to see what the status of stuff is. GitLab question mark. I don't know. Is Austin still in chat? It's definitely not yet, but I wonder how far away it might be. So hopefully Austin's your guy there. So let's see if he chimes in.
And just, if you're doing this, and so I do want to talk about cleanup, but if you're going to keep this open for a little bit after we sign off, I do recommend just create a CI/CD pipeline. I urge you to just walk through this process. It's very simple, and it's really cool to see all the work that Copilot does to get you that CI/CD pipeline, and literally all the work you have to do, which is zero, to make it happen. So
yeah,
definitely test that. But let me touch on cleanup.
Yes, please.
And we please don't leave anything just idle running around. So head to the cleanup compute resources at the bottom here and just check the Copilot portion. And if you created a pipeline, start here. So you delete the pipeline first, but then just make sure you're in one of the service directories, Copilot app delete. Yes. And then it's going to delete all of your services. It'll delete all your environments, so you're not paying for anything that's just sitting idle. So that's pretty much it. I had a lot of fun today. What about you, Brent?
No, he had a great time. No, this was great. I feel like we covered some really good stuff, and we had some good activity in chat. We got a lot of questions answered. We talked a lot about, getting started, getting your containers up and running. By the end of the day, you have, this is so cool. You have orchestrated containers that are running a, production grade, very robust orchestration engine in ECS, managed by a serverless compute plane, Fargate. your interface to everything is an open source tool called Copilot. It is just so cool, so easy to get going. And when you compare it to, what's on the other side of the fence, this is way easier. This is way, way easier. So this is why, like at the beginning, someone asked, how do you choose? This is my starting point. And like, if I can't do it here, then I'll explore other options. But this is always my starting point.
And you remind me really quick that if you ever decide, I love that. Start with Copilot and start there. Again, don't have all this friction if you don't need it, right? Start with Copilot, and then if you decide you don't want to use Copilot, you want to use something else, you can always do Copilot Service Package, and there's all your CloudFormation that Copilot builds on your behalf.
That's
so
right.
Take that and get out of here and do something else.
Yep, exactly.
If you want.
All right. So that's it. We're going to go ahead and sign off. I thank you for coming. We had a great time. Hopefully you did too. And I'm going to pop up the survey one more time. You also have the button to push yourself if you want to take it. And with that, we will be out of here. But you can, like I said, you can always find us on Twitter and the workshop at ecsworkshop.com.
All right.
Thank
you, everybody.
Thank you.
Y'all.